Hello, welcome to the Business Transformation Podcast. Today is our third episode in our series about business resiliency engineering. Hopefully, you've caught the other two episodes. We'll cover those topics briefly in a second. But first, a little bit about myself. If you've never watched one of my podcasts before, I have 28 years in healthcare IT. That's basically my entire career has been wrapped up in one way or the other with respect to performance and engineering. I've set up and run SWAT teams and command centers. I've run incident and problem management processes. I love performance tuning, and we're going to be talking a lot about performance tuning today. Scalability. I've worked on fixed many of the world's largest systems and made them scale. And I've worked on scalability from all aspects, either designing for scalability or all too common, coming in and fixing something after it can't reach that scalability goals of the business. Load testing, we've talked a lot about that in this series. Instrumentation and monitoring, we're going to be talking even more about that today. And most importantly, the culture of system resiliency. So here's our agenda. Today we're on the third chapter, but the previous two chapters, as you can see, we spent the first chapter talking a lot about vital business functions. We'll also be talking about those today, as those are a building block that are very critical. The second episode, we talked a lot about performance testing, a little bit more technical than the first episode. I either whether or not you're technical or a business person, the second episode definitely was a bit more of interest to the technical teams. Today, we're going to continue with that theme and focus on the technical aspects of how you can architect your system for resiliency. At the end of last episode, we had a little bit of a teaser where we talked about common failure patterns that I've seen and how those failure patterns will show up during testing or even production monitoring. Today, we'll be talking about how you can take those things that we learned about, those weaknesses in a system that I've seen throughout my career, and you can architect to prevent those types of issues from happening that we talked about last episode. We'll talk a little bit today about the customer experience and how that factors into our resiliency architecture. And we'll talk a little bit about backlog prioritization. So, architecting for resiliency. And here's a we're going to go through a lot of information rather quickly. So, buckle up. This is going to be fun. One of the most important things that you can do in your architecture is institute rate limiting governors. This is a common failure pattern that can cause your site to go down, which is some type of burst in calls. Now, those calls could be API calls, could be database calls, could be, even asynchronous calls like messaging into a Kafka bus. If those are coming in at a rate that is far outside of what your system was designed to do, unless you have a limit, your system is going to do what you told it to do, which is answer the call. But it can be overwhelmed by too many requests coming in. So, absolutely important whenever you have an external system that's calling into your system. And when I say external, I'm not necessarily saying another company. It could be another system within your environment. But if it's a one system calling another, make sure that you have a governor set at some point, realistically defined, hopefully by load testing, to prove that if you exceed this threshold, the system is just going to tip over. And put a rate limiter in there. Now, a rate limiter can fire in a couple different ways. it can start to add latency into those calls, and in doing so, protect the system itself at, by sacrificing new requests that are coming in. But what this does is it ensures that at least some of your vital business function will still be able to perform up to the level that you have set within that rate limiter. Um, the other thing about rate limiters are how are you going to fail? Kill switch is an interesting aspect of rate limiters. Now, a rate limiter in and of itself is like a governor. Once you hit a certain level, you're not going to allow additional requests in. Uh, you may also want to have a kill switch where if a certain condition is met, that the whole system will shut down. Now, yeah, you may say, Sean, that's not resilient, and I thought this is a resiliency series. Well, you need to make a choice, and once again, this is a business choice, to either protect your system from a failure or allow it to fail spectacularly and potentially really piss off your customers and your users. And so kill switches to me, especially on systems where data integrity, where access to information is tightly controlled, like healthcare or financial information, you got to err on the side of protecting that sensitive data, of protecting your systems. And if they reach a situation where too much traffic is coming in, if errors are starting to just fly left and right and center, kill the system, kill that connection, and potentially the rest of the system will heal and allow itself to go forward and stop that threat. And sometimes that threat is nefarious, right? This is very important. These governors and kill switches are very, very important when creating your security architecture because brute force attacks oftentimes will follow that modality. The attackers are just going to throw piles and piles of garbage or even valid transactions, but just ramped up to a rate that they are hoping to overwhelm your system, and in doing so, open up cracks in the system itself or within your security architecture that will allow them to exploit the crack and compromise your system. Once again, if the system holds sensitive data like healthcare or financial data, or business intellectual property secrets, better to fail than find yourself in court. So, um, but a couple things that are really important with respect to governors and kill switches are think about auto healing. So if the condition is that if the transaction rate, of this specific ingress exceeds 10,000 requests a second, that's too much, kill that connection. But don't just kill it and walk away. If at all possible, have the monitoring watch that connection and see if it returns to normal. And if doing so, it can automatically open up that connection again. Other things about rate limiters and kill switches are a governor that you would place on a system that it in and of itself could go down. So for example, if I'm calling into a back end system like a good old fashioned mainframe, and I'm going to go through a connection pool into that back end system, if that back end system starts to degrade, if the response time starts to elongate, if the throughput starts to go down, then throw that governor, start limiting new requests coming in. Now monitor that connection and see, did it heal? Did that system that you were calling into start to perform as expected again? And the response time goes back down into the expected range, and your throughput once again is hitting your expected range, then automatically turn that governor off. Like all things, make sure the humans are in the loop and they know what the heck is going on. Log these types of governor events, or send information into a common security bus, but definitely log anytime these rate limiter or a governor or a kill switch are firing, so that you can go back later during your root cause analysis phase and figure out what the heck happened and how you can deal with it when it happens again. So the connection pools, connection pools are all over systems, be they a small e-commerce website into massive corporate sites. Ultimately, whenever you're having one system talk to another system, you're going to want to have a connection pool of some sort so that you'll have pool reusability. Typically, reusing database connections or reusing any type of IO handle, if you've established that handle and you can reuse it, that is a very common performance paradigm. So you'll find these connection pools all over a system. Um, if we only think of those connection pools from a technology standpoint, then I'm going to make a connection pool per uh, connected system. For example, the connection pool to my Oracle database, the connection pool to my web services gateway. But I'm going to advocate to think additionally, not only about the technology side, but also about the business side. If there are certain vital business functions that are more important than others, consider putting the most important vital business functions and route them through a connection pool that is dedicated, or infrastructure that is dedicated to that vital business function and segregated from the lower priority transactions or the lower priority connections. Therefore, you now have segregated your vital functions from your non-vital functions. And in an emergency, you could kill off all the connections that are not important, or if the connections to the unimportant system are going out of control, if they're what are spiking unexpectedly, by isolating them from your vital transactions, you're not going to overwhelm your vital connection pool by having these non-vital transactions eat up every possible IO handle or database connection pool or things of that nature. So absolutely, it's a weird idea, and I don't see this very often. And so I would definitely say this is an advanced concept of a very mature organization and a mature system, but it is rather easy to implement. It just takes time and focus. Once again, go back to that very first episode in this series where we talk about vital business functions, and then think about all of the communication pathways throughout your systems and into even your external and partner systems, and see, are there areas where you can set up duplicate or even multiple connection pools, and define those connection pools by the vital business function in order to give isolation between things that matter and things that are a lower priority. So caching strategies. In At the end of the day, if you were to boil down performance and resiliency engineering, almost all of it has caching in one aspect or another. And if you think about even down at the hardware layer, you're caching at disk controllers, you're caching in memory, you're caching in database connection pools where you can execute cached, compiled SQL statements. And then even a browser, right? If the whole idea of a browser cache is like a visitor hits your website, downloads all of those components, if the second click on your website utilizes any of those components that were used in the first click, let's not go all the way back to the data center and pull down a fresh copy of something that you've already got in your cache, right? So I don't want to pick a number, but I'm going to say like 90% of all performance tuning has to do with caching. So absolutely think it through. Now, when you're caching for performance, one of the key concepts to bring in mind is how can I bring the data closest to the compute? And that compute could be pulling a data from a database, putting it into an application server, where that application server is going to iterate through that SQL response and do something with it, right? So obviously, from a cache perspective, um, even before you get to caching, make sure that your database is as close to that app server as you possibly can. And yes, I have seen it, and I'm sure you have too, where engineers have accidentally put app and compute or data and business functions in different regions. All too easy to do in today's cloud computing environment. Right click, new resource. Oh crap, I made that in US West instead of US East or US Central. So think about where things literally physically are located, and then think about how you can take that cached data. And here's the really key point is data concurrency, this last bullet here, where if you've retrieved that information and you're going to retrieve it again, it might even be from a different user. If that information hasn't changed, let's use a cached copy instead of going back to the source. So something very simple could be like on an e-commerce site, the list of products that are available for sale. That could be something that only changes very infrequently. So a cached copy of your goods that are available for the sale could be propagated throughout your entire environment, could be propagated around the world. Based on where your website is consumed, if it's just in the United States, still think about how you can have multiple copies of that cached data located all around the United States so that it's physically as close to your customers as possible. And if it's something that hasn't changed or doesn't change very often, you can easily manage that cached copy. So, but there's a copy of like the concept of write through caching, which is when there is a write, when there is a change to the underlying data, a write through cache is just the right thing to do, which is that new update is going to write all the way through that cache into the system of record and then trigger a refresh of that new information into your cache. So it it takes a lot of work, and but you really have to think about caching in all aspects, even access tokens cached, right? Make sure that they don't last too long, or you're not, on the other hand, churning, getting access tokens every 90 seconds when longer lived access tokens will give all the security that you need, but without having that type of churn that kills your performance. So, resiliency and the customer experience. All right. So when we think about resiliency, it's all too easy to just think of it as a technical problem. To think about how I can make sure that all of my components are up and is functioning at the highest level possible. But part of our resiliency culture that we've been talking about through all these episodes is it will fail. There will come a day when the system will fail. So think about that inevitable failure from the perspective of your end users and lead with empathy. Consider how are they going to experience the inevitable failure of your system, and think about actionable and clear error messages. There's nothing more scary, especially if you're dealing with like healthcare or financial data, than an error message that pops up on a user's screen that looks like a whole bunch of ones and zeros and alphanumeric things, or a message that looks super technical and scary that person is immediately going to, go to that place of, oh my God, what just happened? Is my bank account safe? Is my health information safe? Did I just get hacked? If you have an error message that looks really scary. So it's really, really easy to think about the end user perspective and write that error message so that it's clear, concise, empathetic, and actionable. And so uh, actionable can be the system is going to be down. Call this number. The system is going to be down. Check it again in 1 hour. The system is going to be down. Um, but email your customer support representative. Just keep pushing at it. Make those error messages actionable and clear. It'll also help your technical team. So it's not only for your end users experience, but if you're think and planfully write all of your error messages for all of your failures of your system in such a way that your engineers will be able to understand what just happened simply by looking at the text of the error message that has actionable and useful information in it. And obviously, that's very useful for RCA, right? For the root cause analysis at a later date, you can go back and see what those error messages were saying and understand what happened when you had that system outage. Now, other things about empathizing with the customer is how are you going to fail? Are we going to fail? And we've talked about failing gracefully, but also fail safely. And so once again, if we're talking about very important critical health data or financial data of that individual, always have it fail safely, which is if that write to the system did not completely go through and is 100% verified that it went through, fail it back, and possibly retry it in the background. As I'm seeing right here on one of my recommendations, you can have that retry logic firing in the background. We all know the systems can be transient, even in today's cloud age, where one transaction will fail because of internet gremlins. You do the exact same transaction later, the gremlins are out of the way, and boom, it goes through. So have that retry logic happening in real time. But if a reasonable number of retries, 1, 2, 3, or something like that, are still failing, take that information, cache it, store it, save it, give that error message back to that customer. Hey, your transaction did not succeed, but we have saved your work. And you will be able to take over from where you left off when you come back at some future date. Because once again, lead with empathy. Think about it from your own perspective. How often have you been working on a system, maybe like an insurance website, and you've just spent the last 15, 20 minutes, building an application or searching for plans, something blows up, nothing worse than having to start over again from the very beginning. You're going to get really enraged and do it, enraged users do. So save the members' data as they go along, allowing you to retry their transactions in the background, and then also allowing that customer to retry those transactions at a later date. Also, once again, before we move on from this slide, I did want to also highlight, actionable error messages. If you want that customer to chat with the support staff, offer the chat. If you want them to email, you want them to call, put that number up there. If they're going to go into a waiting room where they're going to wait until the system is available again, let them know that they're in the waiting room. Communication is the key. So input inspection. So this is once again really hitting on the culture that I want all of you to really walk away from this series, which is failure will happen. It is, if it can go wrong, it will go wrong, right? And so, um, from an architecture standpoint, the failure pattern that I've seen over and over again in my career is that the engineers will implement their system with a happy path or Pollyanna approach, where I've got one system calls into the other system, and I'm going to assume that it's there because when I'm doing my testing, everything's great. Then I go live, always there. But if you want to have a resilient system, you need to have coded into that connection. And once again, based on the technology, whether that's a web service call or a database call or a asynchronous messaging bus, you name it, you're going to have a little bit of different way that you implement it. But the analogy that I always like to bring up is climbing a tree. Now, when you were a kid, everyone did this. You go in your backyard or the big old tree at your elementary school and you start climbing it. But what do? As you're coming up that tree, especially when you're coming down, you put your foot on that branch and you kind of push on it just a little bit. Is that sturdy? Yeah, it's sturdy. Okay, I can put all my weight on it. Great. Where's the next branch? Push, push. Okay, that's good. Either climbing up or climbing down, you test your branch before you put your weight on it. You can do the exact same thing in technology. So if you're going to be sending a transaction, uh, is that connection pool available? And before I actually send that information, let me test it. Let me make sure that it can handle what I'm about to ask it to do, uh, because it makes it much more resilient from the perspective of retry logic, much more resilient from the ability that if that branch is no good, you can at least save that information locally, send the error message to the consumer about what's going on, and then possibly retry that connection in the background until it comes available again. So if it's difficult for me to overemphasize how important this is, which is every single component in your system plan for its failure and architect either in the cloud architecture itself, the physical architecture of your on-prem data center, or the logical infrastructure of the logical application infrastructure. Plan for what's going to happen when that resource is unavailable. And there may be portions of the transaction that will still work. This is also very hypercritical when it comes down to thinking of our vital business functions. A vital business function may have a number of different steps. If you think about each one of those steps independently and think about how, if one of those steps fails, can you at least get something accomplished? And if that's okay from your business standpoint, then let it happen. However, the opposite could also be true and is just as important. If in a vital business function, if there are step, and you don't complete every single one of them, you've got to unwind the entire thing, then unwind the entire thing. So another tip, sanitizing all your inputs. The XKCD joke of little Bobby drop tables. I think some of you out there may be of my vintage and you know exactly what I'm talking about. Sanitizing inputs. If any input that's coming into your system, if it's coming from a web browser, if it's coming from one system talking to another system, you need to, once again, have sanitation that will clear out any type of inappropriate data, will validate that all of the data formats are accurate, and not only accurate from the perspective of alpha versus numeric, or meta characters versus no meta characters, spaces, things of that nature. I have probably spent half my career when it comes to resiliency, performance tuning, and availability management, dealing with inputs that were not sanitized. And if the crappy data is let through, that will oftentimes cause failures, cause infinite loops within error handling routines. Once again, Think about all of your data. Think about how it can be checked and validated before it actually gets in your system. Now, obviously, you're all thinking that this is something that is super important from a security standpoint, too. Uh, if the bad guys are trying to break into your system, very well known attacks are all about throwing meta characters, throwing inappropriate information into that input, and then overwhelming the system in a way that allows the attacker to get through. Now, of course, those are easy to think of, and most people will use out of the box or off the shelf tools from vendors that will do that type of security inspection. Great. But in addition to that security inspection, think of it from a performance and availability standpoint, because I have often seen that in my career, even inside one company where two systems are calling each other and one goes haywire and starts sending garbage data over to another system. If those inputs are not getting sanitized, or if there's not a governor or a kill switch that stops that bad data, then instead of having one system that's broken, I have two, possibly a third, a fourth, a fifth, cascading failures. So this bullet right here about save invalid data, very, very important that when you have any type of invalid data, you send that message back to the calling system or the person saying this was invalid data and this is the reason why, this is the acceptable data format, but please save that invalid data in one way or the other. Uh, Especially if you can tie it back to the information about the system that was calling or the individual that was calling, so that as you're doing your root cause analysis, as you're doing your forensics on what just went wrong, you're going to do the however many whys, 4, 5, 6 whys to get to the bottom of what went wrong. And you're not going to be able to do that unless you have saved the data. Great example is your documentation is wrong, incomplete, or unclear. And so your clients don't know what is the appropriate data that they have to send you. And left to their own devices, they're just sending you garbage. If you're looking at that activity, you can start to see a pattern. Oh, wow, this person tried uppercase. They tried it all lowercase. Then they tried with spaces. Then they put an underscore in every space. You can kind of see what that person was going through, and you'll have that aha moment. Oh, crap. I need to, number one, update my documentation. Number two, update my error handling and input sanitation and messaging back to my clients so that they know what data formats are acceptable. So backlog prioritization, our last topic we're going to cover in this episode today. So backlog prioritization is a generic concept that is not specific to availability and resiliency. However, there are some key concepts that I want you all to think about as you start to put together your backlog of ideas. First and foremost is backlog. I'm going to say that word because that is something that we hear mostly in application development, where let's have the business put all of the ideas in a backlog that then can be prioritized so that the developers can write code to fulfill those user stories. Backlog. Um, Resiliency, high availability, and performance are identical in that as you come up with ideas, as you see things going wrong, you've got to have a mechanism. I don't care what it is, even if it's paper. No, let me just say no. Anything but paper. You've got to have that system in a backlog that your team can evaluate. And how are you going to evaluate it? You're going to evaluate it based on your vital business functions. Did this outage that just happened, how many vital business functions were impacted? And of the vital business functions, what percentage? Was it 100% of all transactions that were failing, or was it maybe just 50%? every other one was failing or something like that. And so as you're prioritizing, the first thing you're doing is what went wrong, what were the vital VBFs that were impacted, what was the percentage of that impact, and then all the other additional information. How many users were impacted? And were they all impacted? Like 100% of the users were seeing slowness during this period of time, or were only some users based on possibly where they were located in the country or which office they were working out of, things of that nature. And so you can then start to rank the severity of these problems, and you can rank the fixes that you want to implement. And then as you're making the decisions about what to do first, obviously, what is the likelihood of this happening again? This is an art and a science, but your engineers need to dig into the post mortem of any outage and say, okay, now that we understand that this failure pattern can occur, what is the likelihood of it occurring again? And if it literally is like a snowball chance in hell, just like a once in a lifetime experience, maybe as tantalizing as it may be to go and fix that, fight the urge to just go and fix it until you have actually finished your prioritization. Because the thing that you would not want to have happen is to prioritize the fix of something that's probably never ever going to happen again and have that time, blood, and treasure that was spent on fixing that issue prevent you from doing something that will fix issues that you know are going to occur more frequently. And so, obviously, a lot of work to be able to think all of that through, but it all comes down to doing the needful of what is the impact to the business of this happening again? What is the likelihood of it happening again? Uh, what is the complexity and cost, obviously, of the fix itself? Is this super duper complex, very expensive? Are there other things that we can do to mitigate this issue while we're getting ready to put in the final fix? Uh, and then ultimately make the call and hold yourself to a data-driven approach of these are the things that we're going to fix and this is the order that we're going to fix them in. And if we've all stacked hands on what is the order and what are the prioritization of your fixes, do not allow yourself to be easily swayed by other shiny objects, or in this case, other spectacular failures that might hit your system. And it'll cause you to rethink, but don't completely throw out all of your analysis that you had before about what was the most important thing. If it's still the most important thing, stick through it. And a couple other concepts that we can put in here is as you're trying to figure out your prioritization of your fix, you may be looking at a situation where you need more information. Oftentimes, that can be your first and most important step is get back with your instrumentation and monitoring teams. Is there additional monitoring that we can put around this problematic component or this problematic transaction? Is there additional logging that we can add? Are there ways that we can recreate this in another environment where the sky's the limit, where we can throw debug equals 11, where we can just completely beat the system into oblivion and understand what's going on. So yes, there's are going to be situations where you don't have the data that you need in order to make the prioritization call. I will advocate for don't make decisions in a vacuum. See what you can do immediately to implement systems that will allow you to get more information that can help drive better decisions. Now, obviously, on the other side of the coin is analysis paralysis. Don't fall into that trap. And I find, frankly, the easiest way to guard against analysis paralysis is teamwork, high functioning teams, and a culture of communication but have that culture where you can talk about situations openly and honestly, and call each other out. Getting back to the whole thing about analysis paralysis, you want to be able to say, "Hey, Billy Bob, you're getting too deep into this. It's going to take us too long to get all the information. If we got an 85% chance that the fix that we've come up with is going to do the job, let's test it as well as we can and get that into production as quickly as possible." And so that is the end of this episode. This is our third episode where we talked about architecting for resiliency, the customer experience, and backlog prioritization. I hope you can join us for the fourth and final episode of this series, where we'll be talking about monitoring and alerting best practices, as well as additional concepts around automating resiliency. And if you haven't checked out the first two episodes, I encourage you to check those out too. Once again, I'm Sean O'Neill. Thank you for listening to the Business Transformation Podcast.